Hey everybody, if you know me or follow me on Facebook, you know I love to post little research slides. I like looking at research, especially when it applies very clinically to the patients that we see. So one of the articles that I love just happens to be from Dr. Datis Kharrazian. A lot of people know him, he's the man. And the title of this article is Traumatic Brain Injury and the Effect on the Brain-Gut Axis. I really like this article because we see a lot of patients that come into our clinic that have hit their head and have post-concussive syndrome, and sometimes when we're looking at them neurologically, we forget that it's connected everywhere else, especially in the gut. So we're going to go over this really quick. I just wanted to post a quick video about this. So in his article, he's got two really good images. I love images. They kind of pull me away from all the left brain reading, and I get to see something fun and exciting, and yeah, I get excited about it. So nice images. Thanks a lot, Dr. Kharrazian. But this is a brain-gut axis image. It just shows you how everything's basically connected. The brain up here, you've got your vagal nuclei and your brain stem, and then it points to your gut. So the article goes into basically what happens and how you can get gastrointestinal dysfunction after you hit your head. So the next slide is super cool. This is the other image. I know you probably can't read some of the wording on here, but I'm just going to tell you a couple things that's on it. So trauma to the head can cause disruption of brainstem integration, so that's the brain talking to the brainstem, so you have disruption there. It can have disruption to the insular cortex, hypothalamus, and the corticopontine structures, so that kind of goes into the communication between the brainstem, and the gut, and that loop, the gut-brain axis loop that we see. So there's a disruption there. It gets into impaired vagal motor activity. The vagus nerve is the big nerve that's basically connecting our brainstem, and our gut. And there's a lot of communication traveling up. I call it like kind of the highway in between the brain and the gut. So, impaired vagal motor activity, disruption of the corticopontine integration. I mentioned that earlier, I think. The loss of brain integration. So basically, you've got decreased firing or changes in the frequency of firing of the brain, and that's going to alter the communication that it has with your gut. And then the last thing is a breakdown of the blood-brain barrier, which is a big one. So in our gut and in our brain, we have little, I like to equate them to like screen doors. So our blood-brain barrier is like a screen door. It lets some things in and doesn't let other things in. If there's disruption to the blood-brain barrier, it kind of opens up that screen door, so if you cut a little hole in it, then little flies and bugs can get into your screened-in porch. So if there's a disruption in the blood-brain barrier, we can have disruption in brain activity, and if there's a disruption in the gut barrier, or the gut lining, very similarly, we can have disruption in your gut. So a really cool image. I'll post a link to his article. You can find it online. It's really good. I highly recommend reading through it, especially if you're seeing patients that have suffered from brain injuries. So I pulled out just a couple excerpts from his article. It's, again, a really good article. There's a lot of really good information in it, but I just wanted to read a couple things to you guys. So the gastrointestinal autonomic dysregulation. This is after you hit your head, you develop this sort of dysregulation in your gut. Disruption of the corticopontine projections. So again, for people that aren't familiar with it, corticopontine, so cortex and then pons, which is the middle area in your brainstem. I call it the belly of the brainstem. It's got a lot of good nuclei and things hanging out in there. So disruption of corticopontine projections into the gut that occur specifically after brain injury can lead to various autonomic imbalances called dysautonomia. So sometimes we'll have people come in with all different types of symptoms, and they're not really sure why they're happening, and that's when we have to start looking at the brain and the gut and what kind of communication is happening there. The next slide, and hopefully you guys can read some of this, is the breakdown of the blood-brain barrier. I kind of went into this earlier, but just to go over it again, the blood-brain barrier plays a very critical role in protecting the brain from immune-activating substances. However, widespread breakdown of the blood-brain barrier occurs immediately after brain trauma, leading to a susceptibility to circulating proteins and the promotion of inflammatory sequelae. That's bad news for the brain. It appears that the breakdown of the blood-brain barrier occurs within hours after TBI. So cerebral vascular permeability can increase fourfold within 6 hours of an initiating trauma. So that's bad news. So anytime someone hits their head, we've got to kind of look a little bit deeper and figure out what the heck's going on, because we can have disruption of the blood-brain barrier. Another thing is, another little excerpt I pulled out from the article, reduced intestinal contractibility. So the TBI, if you have a traumatic brain injury to the head, causes a delay and a significant decrease in intestinal smooth muscle contractile activity, leading to delayed transit times. A reduction in transit time can lead to clinical symptoms of chronic constipation, which is no fun for anybody, and dysynergic, defecation. In addition, a delayed transit time increases the potential to develop small intestinal bacterial overgrowth. So this kind of goes into, or SIBO, this kind of goes into, hopefully my head's not cut off in this video, this kind of goes into looking at the brain and the communication of the brain and the brainstem talking to the gut and causing SIBO-like symptoms. So if you're a patient or someone who's suffered from SIBO, we kind of have to say, hey, how is the communication going between the brain and the gut? Because translocation, which means bad bacteria coming in from the large intestine and making its way into the small intestine, translocation happens when there's a faulty valve mechanism. And the only way to keep the valve strong is to basically increase communication between the brain and the gut by doing vagal nerve exercises. So that's a huge thing that we do in our office with patients, especially if we're suspecting SIBO or gut dysfunction. We're going to have them do vagal exercises. So I'll go into that in a second. Last thing, this is kind of in the discussion area of his paper. So basically, as a general rule, TBI can lead to chronic gastrointestinal symptoms through impaired neurological integration involving areas of the insular cortex, the cingulate and hypothalamus, which have bidirectional, so back and forth communication with the visceral enteric nervous system through afferent, which means coming up from the gut, and efferent projections, which means going down from the brain to the gut, into the pontine vagal complex and nucleus tractus solitarius. So again, big words, basically it's just like, hey, if you have a TBI, you're going to have miscommunication in that bidirectional pathway, which isn't good. Alright, cool, so what can you do? Here's 3 quick things, the last one I didn't show a picture for, 3 quick things that you can do to help your, basically increase vagal tone, so increasing activity between the brain and the gut through the vagus nerve. Number 1, sing in the shower. Get loud. Don't do it too early. If you talk to my friend Sachin Patel, he'll tell you to sing, and Jared Sigler, they'll tell you to sing in a cold shower. And there's a lot of good reasons to take a cold shower, so that's another thing you can do. But to specifically increase vagal tone and vagal activity, you want to sing. You want to sing loud. Sing in the car, sing to the ones you love. I sing to my wife all the time. She loves it. Just kidding. So singing. Next thing, gargling. We love this one in the office. Pretty much anybody that comes in, they're going to gargle during or throughout their therapies. So doing big gargles, your vagus nerve likes it better. So if you're being really shy with your gargle, get a little bit louder. The cool thing that we assess for gargling is we'll have a patient gargle, and then the area of the brainstem that's associated with gargling is also associated with creating tears. So if we say, hey, gargle, and they're not gargling hard enough, we ask them, hey, I want you to gargle until you start to develop a little bit of tears. So we're increasing activity in that pontine, that belly area of the brainstem, so it's awesome. Then the last one, the thing you can do, which is really cool, Dr. Kharrazian goes into this in a couple of his lectures. Basically, you can do coffee enemas. Now, when you do a coffee enema, you want to basically give your body enough of activity to increase communication between the gut and the brain. So we like to use gluten-free. A lot of like instant coffees usually have gluten in them, but a gluten-free, maybe like a Starbucks Via Pack. Dr. Kharrazian mentions that. You do the coffee enema, and I won't go into detail, but what you want to do is you want to make sure that when you're doing the coffee enema, you're having to hold in to increase that communication. So if it goes in and comes out and you're not really straining or working really hard to hold in the coffee enema, then you're not really giving your vagus nerve a lot of activity. So I just thought this was really cool. I don't want to go on for too much longer. I could go on for a lot longer about his research article, which is awesome. But this is just a cool little thing about gut-brain, and then also what concussion can do to your gut and how we can maybe use some therapies to fix it. So thanks for watching. I hope you enjoyed, and talk to you soon.